teaching John. Go ahead, John. John, how to do circuits, and I don't think he'll understand anything because he's a bio major, but he was the one I had available tonight, so I'm gonna teach him a little bit about vocabulary. So in this first one, John, we're gonna find out how many loops there are. We're gonna find out how many meshes there are. We're gonna find out how many series there are. We're gonna find out how many parallels there are. I'm gonna explain how to do that, and then I'm gonna write the numbers. And then in this one, we're gonna do that same thing except for branches and nodes. I wanted to do a little bit more complex one for branches and nodes because it's a lot better to explain when there's a lot of them. So I wanted to put those two over here and these four over here. And so the first one, loops. A loop is this is a very informal definition, but a loop is any route that you can take in a circuit that a current could take in a circuit, that any possible route that leads you back to where you started without crossing over where you went. So the first loop's the easiest one. It's all the way around this one. From here, follow that path all the way around. That's our first loop. Second loop is, and I'm doing these in no particular order. Our second loop is right here. Right, that rectangle. Our third loop is this rectangle. And our fourth loop is this rectangle. Right? Those are four different routes that we can take without crossing over our path and ending in the same spot we started. Fifth loop would be something like this. Same thing. It's a continuous path that doesn't cross over itself, that ends in the same spot it started. In our fifth loop, our sixth loop is going to be this one. So the number of loops that we have in this problem is 6. Because of, well, it is true. There's 6 different possibilities. And this is a simple circuit, you know? Compared to that one, it's simple. So, as you can see, there's, 6 loops in something like this. Loops are very common, and there's a lot of them in circuits. So meshes are a little different. Meshes are loops, except there's no internal branches. I guess we're going to explain branches later, but there's nothing internal in a mesh. So in this case, there's only 3 meshes. And like I said, they are loops. So the number of loops in a circuit is always going to be equal to or greater than the number of meshes in a circuit. So here's our first mesh. Here's our second mesh. Here's our third mesh. And that's it. If we took a loop all the way around this thing, it wouldn't be a mesh because there's resistors on that's what those squiggly lines are. There's resistors on the inside of that loop. And so the number of meshes we have is 3. Next one are series. A series is nothing like a loop or a mesh. A series is two or more branches that are in a line with one another, and it's series go along with parallels. They're not the same, obviously, but they correlate. They're in the same field. So there's only one series in here, and there's only one parallel in here. But I'll show you which one's a series. So this one's a series right here because it's in line. Right? And these three are in parallel. These three are in parallel because they're next to each other, like this. And when you're adding and subtracting, I guess not even in that, in everything, you have to be able to identify all 6 of these things, especially series and parallel, know the difference, because I mean they're opposites, really. I mean it's completely different. Both of them are. So right here is a series, right here is a parallel. Okay, so over here we're gonna identify some branches and some nodes. So a branch, I described it earlier, kind of. A branch is any battery, resistor, voltage and current source. Those aren't pictured up here. That's a battery, that's a resistor. All those are resistors. But it's branches is the easiest one to comprehend. Branches are like this right here, this right here, all of these resistors, and so on and so forth. So 1, 2, 3, 7, 8, 9, 10. There's 11 branches in this system. Now we're going to do nodes. Nodes are, so all these lines are wires, really. They're some type of product that is conductant and current can flow through it. And so the wires in between these branches represent the nodes. But the number of nodes correlates to, it stops at every branch. So like for example, this big section right here, sorry, it's gonna be hard to understand if I don't pay attention. That's one node, that big section. See how there's no branches in it? It's all wire, and it's not shared through a branch. This is also one node. I mean, look how little it is. But the fact that it's cut off by both of these branches makes it complete. That's one node. This right here is one node. This here is one node. This here is one node. This is a node. I think that's all of them. Those are all of them. So 1, 2, 3, 4, 5, 6. 6 nodes. And so that's it. Those are all of them.